These are the 6.7 notes for Algebra 2. So it starts with classifying data sets. So it says determine the type of function represented by each table. So my first step in trying to determine what type of function a table shows is looking for the pattern in the y values. When I'm looking at this, I see that to get from 0.5 to 1, I can either add 0.5 or times by 2. I'm going to opt to write down that I times by 2 because looking ahead, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. I can clearly see that the pattern every single time is I am multiplying each y value by 2. And so what this is this is an exponential function, specifically growth. And our reason why is because as x increases by 1, that's how the x values are changing, y is multiplied by 2. This is a common ratio, is what that's called when it's multiplied by the same amount every time. And which when it has a common ratio, that tells you that it is exponential. And if the common ratio is a number larger than 1, then that tells you that it's not just exponential, but more specifically, it's exponential growth. Let's look at another one. So I see the y values are changing. When I look at this, it doesn't look like they're multiplying by anything specific. So since I don't think that they are multiplying by a common ratio, my next step is to do first differences, which we had done previously, first differences, second differences, and third differences, when looking to see if something was linear, quadratic, or cubic. So remember how we did differences is you're taking the right number, the 0, minus the 1 just before it, so you get -2. So then you're taking 2 minus 0, you get 2. 8 minus 2, you get 6, and so on. 18 minus 8 is 10. Tell you what, we'll write that down in the row. You don't have to show your work on this. I just wanted you to see where I was actually getting these numbers from. I normally just kind of do it in my head and write the numbers down. 32 minus 18 is 14, and 50 minus 32 is 18. So first differences were not constant. If this row of numbers was all the same, then I would know the first differences are constant, which means it would be linear. Since they are not, I now need to try the second differences. So for second differences, I do the same thing, just on the next row. I'm taking the right number minus the number just before it. So 2 minus -2 is 4. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4, and 18 minus 14 is 4. This is the second time we did it. This is called the second differences. And when the second differences are constant, that tells you it has a degree of 2. And so if you have a degree of 2, that tells you that it means it is quadratic. So personally, I look for the common ratio first, seeing if the y values are multiplying by a constant amount. And then if I don't have that, then I jump down and I try the first differences, second differences, third differences. Okay, go ahead and pause this video and take a minute and see if you can figure out what exactly the relationship is being shown in both tables on this monitoring progress question. And then unpause and I will go ahead and give you your answer and do a quick explanation. Okay, so on this first problem right here, the y values are being subtracted by 3 every time. So as x increases by 10, y decreases by 3. And so that means that it's linear because the first differences were constant. On the second problem, it's multiplying by 1/3 every time. So that's a common ratio of 1/3. And when it's a common ratio, meaning it's multiplied by the same number every time, then it's exponential. To be more specific, this is exponential decay because the 1/3 is a number that is between 0 and 1. That's what makes it decay. Okay, so the second thing we're going to do is we're going to write an exponential function that goes through these 2 points. So the first thing we're going to do is we're going to use this first set of points to write an equation. So using this format, y equals ab to the x. We have 1 is x, 6 is y. So y equals a b to the x. Y is 6. We don't know a. We don't know b. And then x is 1. Now do the same thing with this other point. y is 54, we don't know a or b, and x is 3. So your first step that you're going to do is you're going to write two equations using the 2 points that were provided. Okay, your next step is you're going to take one of those equations and you're going to rearrange it to where a is by itself. This is going to let you use substitution. So I'm going to take this equation, the 6 equals a times b to the 1. Keep in mind, that's the same as 6 equals a times b. Now, if I want to rearrange this equation so that the a value is by itself, I will divide by b. So I now know that a equals 6 divided by b. So I can take this and I can substitute it in for the a. That's what I'm going to do. So here's where I'm at. I have 54 equals, and instead of a, we're going to plug in 6 over b, and then times b cubed. Just instead of a, I plugged in 6 over b. Okay, so let's go ahead and let's simplify this. We're trying to find a and b. So right now I'm finding b. So I have 6b cubed over b. Well, if I have b cubed over b, that turns into b squared. So I have 6b squared. So I divide by 6. I get 9 equals b squared. And then I square root both sides. And I end up with 3. Now, the reason I do not use plus or minus 3, I just use positive 3, is because by definition of an exponential function, the b value is always positive. And so when we're saying a times b to the x, we know the b value must be positive, so that's why I only use positive 3. Okay, so now that I have b, go back in to this equation, and a is 6 over b. Well, if b is 3, 6 over 3 is 2. So now you're ready to write your answer. You have y equals a is 2, b is 3 to the x. And that's the exponential equation that fits the 2 points they gave us. All right, let's go ahead and try another one. So the first thing we're going to do is write an equation with this first set of points. So y equals ab to the x is 2. And with the second set of points, 24 equals ab to the x is 3. So then you take one equation, I usually do the one with the smaller power, and rearrange it so that a is by itself. So that would be 12 over b squared. So we're going to take this 12 over b squared, and we're going to use substitution, and we're substitute it in for that a. So we have 24, and then instead of a, I have 12 over b squared, and then I still have b cubed. So I just substituted it in. Okay, so where that gets me is I have 24, b cubed over b squared will cancel to just b. And so that's where I'm at. I divide by 12, and I find out that 2 is what b is. And then I'm going to go back in here, and I'm going to plug in the 2 for b. So I have 12 over 2 squared, which is 12 over 4, which is 3. So the a value is 3, the b value, is 2, and to the x. And that's my answer. Go ahead if you want to try 4, pause the video, and I'll come back on and project the answer so you can check yourself. All right, here's the solution to this problem. Go ahead and pause it if you'd like to look at it in more detail if you did not get it correct. Okay, so last but not least, we're finding an exponential model. And so this is telling us that it is y is the number of trampolines that were sold, x is the number of years that the store has been open, and it asks us to write a function that models the data. So the first thing I want you to do is you're going to take your graphing calculator, and you're going to go to Stat, and hit Enter on Edit, and I want you to stop and type in x as L1 and y as L2. I'm going to pause the video and come back with that done. Okay, so I have my data in my list, and keep in mind that it asks us to specifically find an exponential model. It did say to make a scatter plot and use a calculator to find the model. So I'll show you how to do both at the same time. So you're going to do Stat, you're going to go over to Calc, and you want the one that talks about exponential regression. So you have to scroll down here. On my calculator, it's 0 exponential regression. So you're going to hit Enter on that, and you have L1 as X, L2 as Y. Go down to Calculate. All right, and we have our equation here. The A is 8 point, we're going to call this 46, The B is 1.418, and you can see the format there at the top. And so you're going to go ahead and have 8.46. The B is 1.418 to the X. Okay, just to show you real quick how you can do that, when we did stat, calc, and we opted for 0, and we were in here, before we hit calculate, where it says store regression equation, this is where we can go and we can have it store it into Y1, and we can go have it graph what we want to have graphed. So what we can do is, where it says store regression equation, hit the variables button right here. It says vars, it's for variables. Go over to Y variables, hit enter on this first one that says function, and hit enter on Y1. And now when you go down to calculate, it's storing this equation we just made into Y1. So now if you go to graph, my graph is weirdly zoomed out from something else. So what I can do is I can do zoom, and I want to do the one that says zoom stat. And what it's zooming in on is whatever you put in your stat area, like when we did that table. So hit enter on zoom stat, and should go ahead and graph it. All right, I had to play with it for a minute. So to get this to work, what I had to do is when you go to y equals and you see up here it says plot 1 at the top, I had to turn my plot on. How you do that is you hover over it to where your cursor is on it and you hit enter. In this case, I just turned it off. I'm going to hit enter again. It needs to be selected in black there to have the plot on. And then you go to graph and you can see there's my scatter plot of the dots. That comes from the table versus the curve comes from the regression equation that I just had it do. You can also mess with your window. I knew my window needed to go from 0 to 8 to fit 1 to 7 in there. And then looking at my Y values, my highest was 96. So I made my Y max 100. And that's how I was able to get it to all show up. Okay. So this gives you a story about air pressure and altitude. And it specifically tells you, not just in the instructions to find a logarithmic model, but it also shows you right here that this is the format they want this model to be in. Take note of the variables they give me, because if we're typing this in on Big Ideals Math, we're going to have to use their variables also. So what I want you to do is I want you to stop, and in your calculator, I want you to go to stat, and in L1, I want you to put the air pressure, and in L2, put the altitude. Go ahead and type those in real quick, and then press play again. Okay, so from here what I do is I go to stat, I go over to calc, and I'm looking for natural log regression. They specifically said use natural log if you look at the format that I had highlighted. So L1 is X's, L2 is Y's, yes. Go ahead and go down to calculate. So my A right here is 0.86 plus the number in front of the natural log is B. So it's negative 6.45, so I'm going to use minus. And then the R values, if yours don't show up, it's fine. They're just showing how strong the fit is. So what we have here is I had Y equals, I had 0.86. It was negative, so I'm going to put minus. The B value was 6.45, natural log of X. But keep in mind that they specifically said they want it to be H equals, because instead of Y, it's H. And then instead of X, they had P. So like if we were doing this online on our homework, we would have to make sure we change those variables. Now they say to estimate when the atmosphere pressure is 0.75, and so that's the P. So what you're going to do is you're going to use your calculator, and you're just going to plug in 0.75 in for the natural log, and do that in your calculator, and you get that it's 2.7 kilometers. So the air pressure is 0.75. Then you have 0.75 kilograms per square meter. Then the height or the altitude you're at is 2.7 kilometers high.